run the test. And we're just checking to make sure that the levels are all set. We're hitting the right profile, starting at 5 hertz, going to 2000 hertz in 2 minutes, doing one sweep. Channel 1 sensitivity, channel 2 sensitivity, 3 and 4. Channel 1 is our control. So we're going to press OK to continue. And we're going to just disregard that advisory. And we are moving on. The screen should clear. And we're going to start to see input. Input channel change. Starting at 5 hertz, you can see the little bug on acceleration coming up here, targeting a tenth of a G at 5 hertz. You'll see it rise. At the same time, you should be able to see the accelerometer table moving. It is moving. All right, we captured a tenth of a G. Now we're going to increase frequency. And there's the bug that tells us our frequency. At the same time, you can see the beam deflecting as the load increases. When we hit resonance, the beam will respond dramatically. There will be a lot of motion in the beam, and you'll see a spike in the output acceleration. Now we're up to 1 G of acceleration. We're at about 16 hertz. Moving on up. Now because this is a short beam, the displacement deflections aren't going to be very high. Coming up on just past through 30 hertz. Again, holding the input at 1 G of acceleration. Now once we get up to about 100 hertz, did you see something? All right. That was a resonant frequency. At about 100 hertz, you're going to start to hear an acoustic component. Now that's that low frequency. That's coming out of the shaper table, and that will steadily increase. Look over here, you can see the peak acceleration measured on each of the channels. We should only get 1 G on the input, channel 1, but you can see these on the output side spiking up to 13. That was almost 70 Gs on channel 3. Passing through 600 hertz now. You'll notice that the rate of increase of frequency is not a linear increase. We're actually increasing in frequency logarithmically. Closing in on the end of the test here at 2000 hertz. Test will be over. There we go. Now we've captured the data. Now Word will automatically open up and will allow us to take a look at the data as a output product from the system. That's raw data from the accelerometers. We're going to dismiss that. And I want to show you what the accelerometer format looks like. We're going to go View. We're going to select Spectrum. We're going to select Channel 1, Channel 2, Channel 3, and then Channel 4. Click on OK. Now there is a plot of the raw data from the test that we just ran. Let's go and grab that corner up there, make it bigger. So this is the input profile right here. And the wiggly lines are the outputs. So channel 2 is the blue line here. Channel 3 is the orange line. You can see that channels 2 and 3 spike here at a certain frequency, along with this guy right here, which is channel 4. Channel 1 is inputting this 1 G of acceleration, but the output here, we are almost at 100 Gs of output response on channel 2 there. So it's really, really important to know where those accelerometers are located so you know what is causing that and the bending mode shape of the beam and that test. As we continue on up in frequency, you can see that this orange one drops down into a pit here. It's an important observation. Here, this accelerometer is picking up almost 0 G's of acceleration, while the input is at about 1 G of acceleration. What's going on there is that this accelerometer is mounted on a node on the beam. And that's a place on the beam that's moving relatively little as it's being excited. Right? So there's not much acceleration going on. In other words, the beam is rotating about that point. Here we see a spike in this accelerometer, and the other two accelerometers aren't really doing it. This accelerometer, channel 4, if we look, we would probably find that to be mounted on the transverse surface of the beam, which means that this input acceleration is exciting a transverse vibration mode in the beam. So when we're counting resonant peaks, the first peak is right here, somewhere at around 60 to 70 hertz. The second spike is here, probably at about 200 hertz. And then we've got another one out here, and one out here. So those are the resonant peaks that we're concerned with. The primary one that we actually picked up is right here. Now we may do an analysis and find that there's a resonant frequency below 500 hertz, or below 5 hertz, I'm sorry. So if that's the case, then this test will not pick up that resonant mode because we started vibrating at 5 hertz. So analytically, you show that there's a resonant peak below that. Notice that we're not going to pick that up there. So I hope you're able to hear all that through the noise. We're going to move on to the next test, which is a short lumen beam oriented 45 degrees relative to the